For 44 years now, Voyagers have been moving farther and farther from the Earth while exploring the solar system and interstellar space. All data we currently have about Uranus and Neptune was found by Voyager 2, while Voyager 1 collected the first data ever about interstellar space. But the most well-known fact about Voyagers is, of course, that aboard both of them, there were 2 golden records that contained information about Earth and humanity. However, Voyagers might never have been launched. In the 60s, the Congress of the United States was too involved in the arms race with the USSR. NASA was pursuing one goal: to land an astronaut on the moon. Thus, it spared no effort and no expense to complete the Apollo program. Congress was no longer interested in space after winning the moon race. Funding for NASA projects was cut almost fourfold. Only a person totally obsessed with their idea could try to advance a new large-scale solar system research project. Fortunately, a young graduate student, Gary Flandro, was working at NASA at that time. He was obsessed with an ambitious idea to send a spacecraft to Neptune. In this video, I'll tell you who launched Voyagers, marketers, or space engineers. How many times does a scientist have to sit their ego down to fulfill a lifelong ambition? And what could possibly go wrong with the Voyager interstellar mission? In 1964, a young scientist, Gary Flandro, started working at NASA's Jet Propulsion Laboratory. And no, he didn't start out as a paper pusher or an assistant. He was immediately entrusted to solve a complex problem: how to launch a spacecraft beyond Mars to the solar system's outer planets. Back at that time, scientists dispatched spacecraft to the Moon, Venus, Mercury, and Mars, but no one knew how to get to the gas giants such as Jupiter, Saturn, Uranus, and Neptune. To escape the gravitational pull of the Sun, it takes a huge rocket, thousands of tons of fuel, and 30 to 40 years to fly. However, Flandro was sure that there was another way. He spent a whole year studying the works of modern space engineers and experts in celestial mechanics, but he still didn't come to the solution. The fact that added fuel to the fire was that another young scientist, mathematician Michael Minovich, also decided to find a way how to fly to the outer reaches of the solar system. Minovich was a UCLA graduate student and a summer intern at the laboratory where Flandro was working. A PhD student with no spacecraft experience decided to take on the most complex problem in celestial mechanics. Minovich carried out his calculations on the most modern available computer at that time, IBM 7090. The University of California had to pay $1,000 for an hour of its use. Just imagine Flandro's reaction when he learned how many thousands of dollars were spent on the calculations. His research wasn't funded that generously, but that generosity produced results. Minovich's equation showed that gravity assistance can be used to move around the solar system. The spacecraft's speed increases as it approaches the planet, which allows it to speed up without wasting a single drop of fuel. Minovich's breakthrough could get Flandro's research off the ground. But for this, he, as a space engineer, would have to make his calculations based on a student's equations. Flandro ignored Minovich's work for a long time, calling it too abstract. But the dream of interplanetary travel turned out to be bigger than the scientist's ego. Flandro still considered the trajectories Minovich calculated were inaccurate, but the idea of using the gravity of Jupiter and other planets to maneuver led to a grand discovery. Flandro calculated the ideal time for a slingshot maneuver for future Voyagers. It turned out that Jupiter, Saturn, Uranus, and Neptune would all be on the same side of the solar system in the late 70s. Thus, their gravity could sling a spacecraft past all 4 planets within 10 to 12 years, getting to the outer reaches of the solar system. But they had to hurry up. Such an opportunity would not present itself again for another 176 years. There wasn't much time left. The scientists had to convince the U.S. Congress to provide funding for NASA, build spacecraft that could fly to Neptune, and launch them on time. Do you have any idea at what point things didn't go as Flandreau planned? Congress had already reduced NASA's budget, and this ambitious project required around $700 million. In the summer of 1970, the Space Science Board was choosing projects that could receive funding from the U.S. Congress. 90 scientists presented their exploration missions over 3 weeks. Flandreau was a scrupulous space engineer, but a terrible marketer and speaker. He failed to explain to the council why it was essential to launch Voyagers at that very time. That was a huge flop. It took NASA a whole year to convince the community of scholars of how important Voyagers were. Scholars, but not the U.S. Congress. The government didn't want to risk tax money and approved only a shortened version of the mission. NASA was provided with funds only for the 2 probes to reach Saturn. That was the end of Flandreau's idea. The launch window was fast approaching, and design work on Voyagers hadn't even started yet. That's why Flandreau, along with the team of engineers, decided to ignore Congress and design both probes in a way that they could reach Neptune. It was a hard thing to do with only half of the budget. The first thing they worked on was reducing fuel consumption. Consequently, the probes could send signals to Earth for a couple of decades after flying past Saturn. Besides, engineers modified sun sensors so that Voyager could function far away from the sun. And most importantly, aboard the probes, NASA installed 5 devices meant to analyze space beyond our solar system. But sending the probes farther than Saturn required funding from Congress. After his past failure, Gary Flandreau knew better than to talk, so he gave up to the idea of seeking the involvement of someone who could promote Voyagers around the world and thereby leave the government not much choice. That someone was
Carl Sagan,
a famous astrophysicist and science popularizer. He was well received both at The Tonight Show starring Johnny Carson and at Congress meetings, and he also had access to Jet Propulsion Laboratory that designed Voyagers. But Flandreau immediately regretted supporting Sagan. That's because Sagan proposed the idea, which scientists at first found not only crazy, but even preposterous. He suggested sending a message to aliens, the Golden Record, together with Voyagers. Sagan had already designed records with messages for Pioneer 10 and Pioneer 11 probes. Back then, the message had sparked tremendous interest in people who had nothing to do with science. This time around, Sagan decided to send to space not only pictures, but also a whole record containing sounds that can be found on Earth. For Flandreau, that sounded like closing the door on his career as a scientist. Voyagers he worked on for over a decade risked becoming a laughingstock. If Congress refuses and the mission fails, the whole world will remember Flandreau as the person who recorded songs for the aliens. But at that time, it was the only way to send Voyagers to Neptune. A special committee, headed by Sagan himself, spent a whole year selecting content for the Golden Record. All that was left to do was to present the idea to Congress. Flandreau already screwed himself for the sake of Voyagers. He had to use the calculations of his competitor Minovich and defend his idea in front of a crowd of scientists. But the Golden Record was too much. Or not.
3, 2, 1. We have ignition and we have liftoff.
Flandreau's arduous struggle with himself ended with the victory of Voyagers over his ego. The U.S. government agreed to allocate money for the extended mission. Everyone seemed to immediately forget how much Voyagers cost. Congress and the public were busy discussing the content of the Golden Record. And on August the 20th, 1977, the first spacecraft, Voyager 2, went into space. But that wasn't the end of the story. Marketing ploys and the golden record could convince Congress, but all recognition went back to space engineers after Voyagers were launched. A fuel leak occurred on the launch rocket that was supposed to bring Voyager 1 to outer space. That could cause a lack of thrust, meaning that the probe would never make it to Jupiter. Fortunately, the scientists designed the onboard computer so that it was able to react promptly and use reserve fuel to generate the needed thrust. If something went wrong, it's terrible to imagine what could happen to Flandro and the whole team of the Voyager mission. Gary Flandro wouldn't have become an honorary PhD and the vice president of an aerospace company. Michael Minovich would have probably been deprived of the NASA Distinguished Service Medal, and only Carl Sagan would have continued to participate in The Tonight Show and make inspiring space travel videos.